In this lesson, we'll be focusing on the rational root theorem. What you see listed on the screen is a polynomial at the top, and what the rational root theorem says is all of the possible roots of a polynomial can be determined by taking the ratio of p over q. Now, I've listed p and q at the top in red. P would be the value 2, and q would be the value 6. So all of the factors of p over q, and I've listed the factors of p, plus or minus 1, plus or minus 2, and the factors of q, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And in writing the possible roots, we have to take the form p over q. And so what you have to do is write the factors of p over all the factors of q. So there's 4 sets, if you will, 4 sets of q with p on top because there's 4 values of p. So I'm going to write that out in longhand. Starting with the first value of p, it would be 1 over 1, negative 1 over 1, 1 over 2, 1 over negative 2, 1 over 3, 1 over negative 3, 1 over 6, 1 over negative 6. So we've done the first part of the rational root theorem, and we've just done the positive ones for p, but we had to do all the values of q at the bottom. Now we repeat the process, and we use the next value of p, which would be negative 1, and we would do negative 1 over 1, negative 1 over negative 1, negative 1 over 2, negative 1 over negative 2, negative 1 over 3, negative 1 over negative 3, negative 1 over 6, negative 1 over negative 6. Now, if you'll notice, several of these values repeat. 1 over 1 repeats, negative 1 over 1 repeats, 1 over 2 repeats, negative 1 over 2 repeats, 1 over 3 repeats, negative 1 over, they all repeat. And so the shorthand to writing all of this would be to combine our plus or minus 1s for our p values. So we would do plus or minus 1, and then we would write the consecutive values of q. So plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over, not 4, I don't know where I got 4 from, plus or minus 1 over 6. So those are the first values of p over q. Now we would take 2 and negative 2 and do the same thing. So we have plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 2 over 3, plus or minus 2 over 6. Now some of these, like plus or minus 2 over 2, is the same as plus or minus 1 over 1, because 2 over 2 is 1 over 1, or 1. So typically we would rewrite that as a 1 value. So we could scratch through these two, and we would write plus or minus 1. The plus or minus 2 over 1 will be written as plus or minus 2. And the plus or minus 2 over 6 can be written as plus or minus 1 over 3, but we already have a plus or minus 1 over 3, so we can eliminate that. You always want to look for duplicates and make sure that you get rid of the duplicates. So I think we've pretty much covered our bases. Now we can rewrite the final answer, and I'll put it in a different color. Plus or minus 1, plus or minus 2, plus or minus 1/2, plus or minus 2/3, plus or minus 1/3. I should have written 1/3 before the 2/3 because you want ascending order. So these would be the possible roots of this polynomial. Now notice all of them can't be roots. Why? Because we have a third degree polynomial, so a third degree has 3 possible roots. So only 3 of those roots can be at the bottom can be an answer or be a root. So it's up to us at this point to determine which one those are. So we can use synthetic division. we can use the remainder theorem, either one, to check and see which one is the root.